This is an introduction to air pollution. When Rachel Carson lists all of the assaults that mankind has imposed on the environment, it's no coincidence that air is number one. Clean air resources are critical for all living things. Air pollution refers to the release of pollutants into the air that's detrimental to either human health or the environment. Air pollution can be a mix of particles and gases that reach harmful concentrations, both outside and indoors. Its effects can be wide-ranging, from higher disease risks to rising temperatures. The aim of this discussion is to gain an understanding about how human activities have physical, chemical, and biological consequences for the atmosphere. The learning objective is to identify the sources and the effects of air pollution. The discussion will center on how the combustion of fossil fuels results in the release of caustic air pollutants. I will also provide a general overview of how primary pollutants become secondary pollutants, as well as an overview on the Clean Air Act. One of the common through lines in pollution, from solid waste pollution to aquatic pollution to air pollution, is the definition of risk. The two component parts of risk is the ability of material to cause harm and then exposure of that material to either human health or the environment. Air pollution specifically is the introduction of material into the atmosphere at a concentration high enough to cause harm. Air pollution can come in three major categories: chemical, particulate matter, or microorganisms. One of the things that's so unique about air pollution compared to aquatic or solid waste production is how air is a shared common resource and how quickly air can move through the atmosphere from one geography to the next. Primarily, air pollution can cause harm because it alters the abiotic factors inside of the ecosystem, which can stress the range of tolerance for plants and for animals, and that same ability to cause harm can also cause breakdown to human structures such as buildings. In this preliminary discussion of air pollution, we'll focus very generally on the sources of pollution. Natural sources include things like windstorms that kick up dust and particulate matter that gets suspended into the atmosphere, volcanoes that release sulfur dioxide and ash, forest fires that as part of their chemical combustion processes release carbon oxides and nitrous oxides and soot, plants that can release pollen and hydrocarbons, and ocean that can kick up salt. Anthropogenic sources include things like transportation, industries, combustions at stationary sites like the combustion of fossil fuels, and waste disposal, things like incineration. The key distinction between natural and anthropogenic isn't so much just that the source is different, but that natural sources tend to be much more dispersed even though they can be in higher volumes, and they also tend to vary or be sporadic by season, where anthropogenic sources are localized and concentrated and emitted at high rates throughout the year. The atmosphere is unique in its ability for chemical reactions to occur, and it's important to understand the distinction between primary and secondary pollutants. Primary pollutants are those that are directly emitted by the source. They include things like hydrocarbons, nitrogen oxides, sulfur oxides, carbon oxides, or particulate matter. Once these pollutants make it into the atmosphere, they can mix with each other or with other atmospheric components like water vapor to form secondary pollutants. Secondary pollutants include things like photochemical oxidants, nitric acid, or sulfuric acid, and usually these secondary acids have a higher ability to cause harm to human health or the environment than the original primary pollutants themselves. This table comes from the Plain English Guide to the Clean Air Act from the Environmental Protection Agency, and it details how primary pollutants become secondary pollutants. Starting at the top level, you have anthropogenic sources such as cars and industry. What's important to note is that the combustion of fossil fuels, especially coal, for energy production produces a large amount of toxins that go out into the atmosphere. In the second level, you see the primary pollutants that are produced: carbon dioxides, carbon monoxides, hydrocarbons. All of these already cause harm in the environment. Nitrous oxides, particulate matter, and sulfur dioxides combine with other toxins and other components of the environment to produce secondary pollutants in the third level. Secondary pollutants are things like ground level ozone that becomes one of the main components for photochemical smog, or acid deposition, which is the combination of nitric oxides and sulfur dioxides with water vapor. Particulate matter can combine with sulfur dioxides and water vapor to create sulfurous smog. The effects of these pollutants can be wide-ranging. They can affect human health, they can cause global warming, and they can affect the ecosystem or damage the ozone layer. I want to pause and note that there's a key table, 46.1, in the textbook on page 521. In this table, you'll find a list of air pollutant compounds and their associated chemical symbols, their human-derived sources for each, and the effects and environmental impacts for each. You should spend time committing the information in this table to memory. On the left is a more detailed breakdown of the anthropogenic sources of air pollutants. What's key to note is that most air pollution comes from energy use and energy production. Because fossil fuels are not pure hydrocarbons, there are three main gases that are emitted during the combustion of fossil fuels. They are the primary pollutants: sulfur oxides, nitric oxides, and carbon oxides. Sulfur oxides and nitrous oxides are extremely important to remember because they are both primary pollutants that transform into secondary pollutants such as ground-level ozone or acid deposition. Though many things emit carbon dioxide when they breathe, the gas is widely considered a pollutant when associated with cars, planes, power plants, or other human activities that involve the burning of fossil fuels such as gasoline or natural gas. That's because carbon dioxide is the most common of the greenhouse gases, which trap heat in the atmosphere and contribute to climate change. Humans have put enough carbon dioxide into the atmosphere over the past 150 years to raise the levels higher than they've ever been seen for hundreds of thousands of years. John Walk, the director of the Clean Air Project and part of the Climate and Clean Air Program at the National Resource Defense Center, says the burning of fossil fuels releases gases and chemicals into the air, and in an especially destructive feedback loop. Air pollution not only contributes to climate change, but is also exacerbated by it. Air pollution in the form of carbon dioxide and methane raises the Earth's temperature. Another type of air pollution is then worsened and then increased by heat. Smog forms when the weather is warmer and there's more ultraviolet radiation. Climate change also increases the production of allergenic air pollutants, including mold and pollen. Air pollution isn't just a problem for the environment, it's also a global health hazard. Poor air quality flat out kills people. Worldwide, bad outdoor air causes an estimated of 4.2 million premature deaths per year, and according to the World Health Organization, about 90% of those deaths are in low and middle income countries. Indoor air smoke is an ongoing health threat for about 3 billion people who still cook and heat their homes using biomass, kerosene, or the combustion of coal. Air pollution has been linked to higher disease rates of all kinds: cancer, heart disease, stroke, respiratory diseases like asthma. And according to the American Lung Association estimates, in the United States, nearly 134 million people, which is about 40% of the population, is at risk of disease and premature death due to air pollution. However, there's been a huge amount of progress over the last 40 years in improving the air quality in the United States, thanks to the Clean Air Act of 1963. This is an act that became a United States federal law and is designated to control air pollution on a national level. It's usually touted as one of the most comprehensive environmental laws of the world. It's also a great example of the Kuznets curve because the law enacted a lot of American innovation and invention that led to the reduction of pollutants over time. So since 1970, this graph shows from 1980 through about 2015, you can see all of the air pollution is going down while the gross domestic product of the United States is going up. Since 1990, there's been about 50% decline in reduction, and below you can see a detailed list of how much reduction there's actually been in each one of the key pollutant areas. Despite decades of progress, though, the American air quality has started to decline over the last few years, according to new data published in the summer of 2019 by the Environmental Protection Agency. The agency recorded about 15% more days of unhealthy air in the country in 2018 and 2017 compared to the average from 2013 and 2016. And although the reasons for this decline is a little unclear, according to the agency, it may be related to the increased number of wildfires, warming climate, and the increased human consumption patterns driven by population growth and a strong economy. So it'll be key to watch that climate change can make it harder in the future to meet pollution standards which are designated to protect human health.